Welcome to another episode of Code for Thought. One of the fundamental principles of science is that when you run an experiment and you get some results from which you draw some conclusions, someone else can go and repeat the same experiments to see if they can reproduce the same results, or at least take your data and see if they can come to the same conclusions. To some extent, that is what the review process in scientific publishing is doing, or supposed to do. But research is increasingly based on software applications and data analysis tools, and these tools and applications can be very complex, and the amount of data they produce can be absolutely gigantic. Far too complex and large to be covered in a few pages of a PDF, a scientific paper. So who's checking the data then, and who makes sure that the software researchers use is doing what it's supposed to be doing? Over the years, many researchers have become worried about what they call the reproducibility crisis. Luckily, there are initiatives to address this, one of which is the Reproducibility Network in Germany. In 2023, I had the pleasure to meet with two of the representatives of the network, Rima-Maria Rahal and Peter Steinbach. Rima and Peter come from very different fields, psychology and physics. But reproducibility is something that transcends scientific domains, as Rima and Peter will explain in the following conversation. Hello Rima, hello Peter, welcome to the show. Before we start talking about reproducibility and Reproducibility Network in Germany, could you please introduce yourself quickly? Let's start with Rima and then go over to Peter.
So I'm Rima, and I'm a researcher at the Max Planck Institute for Research on Collective Goods in Bonn. I'm a psychologist by training, and I'm a member of the steering group of the German Reproducibility Network.
Hi, I'm Peter. I'm leading a group of Helmholtz consultants for the research field of matter, so that is mostly physics. And I'm also a member of the steering board of the German Reproducibility Network.
How big is the network? Let's start with that.
The last time I checked, the network was 30 member initiatives and more, so we're growing. We also have several institutional members, such as the German Psychological Association. And in the steering group, there are 12 individuals.
That was my next question, how many members the steering group has. You're two of 12, basically.
Yes.
Okay, so let's start with why do we worry about reproducibility and why is it important?
Basically, the issue or the challenge stretches along and around many domains, and I think it started mostly in psychology. Maybe Rima can comment later. But what I see is that the more we use code and software to analyze our data and to obtain insights about whatever phenomena you're interested in your scientific day-to-day work, we see that especially working with this, it's actually most challenging for a lot of people to get this code right, get the code to produce the same results over and over again. And this simply has to do with the fact that a lot of times in the physical domains, for example, but also in other domains, people are typically not trained to use software and to write software to obtain insights. So that's basically, from my perspective, the core challenge that we see across the board.
So Rima, Peter mentioned psychology where it all started. Is it a big problem in psychology then?
Well, the size of the problem is different, I think, in different fields or disciplines, depending a bit on the kinds of methods that are being used. But it's not just a problem in psychology. I think it would be fair to say that it's a problem in other research areas as well. So there have been investigations, for instance, in behavioral economics or cancer biology, where similarly alarming numbers were prevalent. And the exact numbers differ by field, but it is a problem more generally in research. And I would say that the problem is that in experimental research, that we try to run an experiment again, something that's already been done. We are trying to see if we can do it again. Sometimes it just doesn't work out. And so this could be because of somebody's code just not giving us the same output that it gave in the publication, or it could be because of other reasons. But the idea of lacking reproducibility and replicability is that it's difficult to do the same thing again. And we are looking in experimental research often for something like law-like effects, for robust effects that we can find again, not just in a one-shot example, but we're trying to learn something about the state of the world. So given that, it would be really important that there is replicability and reproducibility so that we can see things again that somebody else has already tried to do. And if that's not present, then that's really a problem.
I mean, you're two representing two different areas. So, Rima, you're in psychology. Peter, you're more in physics. Well, now in AI, but you have a physics background. So, from the two domains that you're both working in, so what's your estimate? How much of the research that's being out there is reproducible, or the other way around, how much is not reproducible?
To my knowledge, in physics, there are only very specialized studies on this question. So there's no broad study being conducted, at least as far as I know. There are some minor surveys that I'm aware of. Ask the same question to the community. What's your estimate? And so I can give you my personal number. My personal number is 50 to 75% in physics are reproducible, but this totally varies. What your personal standard is, that's the first thing. So what is your level of confidence where you think, this is reproducible, it's fine. But I think Rima already mentioned a very crucial point, namely the robustness of evidence. How robust can I really say or make the inferences I do? In physics, my experience is that at an academic level or metaphysical level, this is typically very good. However, if you dig then down and ask people, can you give me your code? Can I use it to reproduce your results with an open data set? Then it becomes very quickly very brittle. So not sure about you, Rima.
I think in my research area, I attempt to quantify how good we are at in terms of computational reproducibility. I'm not aware of any actual hard numbers on that. What I am aware about is evidence about replicability. There was a project in psychology where out of 100 previously published experiments, they tried to run these again, and only about a third ended up showing an effect in the same direction. So this means about a third, depending on which metric you use, only about a third would be replicable. And I mentioned before, behavioral economics, we have similar numbers. I think the number is a bit higher. In cancer biology, the number is actually lower of studies that were found to be reproducible. From a perspective of can we rerun experiments and find the same result, I think we often have to be very doubtful about the robustness of published findings. But I think things are changing a bit. So newer studies where people make their code publicly available and say that they do so, for instance, in their manuscript already. I think the trust that I would place in this research is a bit higher. Also because I can go ahead and see if I can reproduce the analysis that I see in the paper, if I can reproduce the data preparation that was being done. Given that we are making steps to make data and code publicly available more and more for published research, things are looking up, but it's with the historic literature is still a problem.
Yeah, I was about to ask, because when we talk about reproducibility, we are talking about actually a lot of different things. So first of all, there's the code itself. If we're talking about reproducibility of software. And then there is, of course, the data themselves. Let's talk about the software first. You too mentioned it, that the code may not be available. Is that the main problem then of reproducibility, that people don't make their code publicly available? Or is it more a problem of, well, they make the code available, but the code doesn't work?
I think that's the nice thing about our community, because we have all of those. You find all of those. I would even guesstimate to equal ratio. As I said before, for me, the core challenge is really the educational part. But in any case, there are still some closed journals that really don't publish the code, and there are reasons for this. Also, we in Germany have these reasoning, especially as if you start to talk to people from the technology transfer, then they get very cautious very quickly. But in any case, I totally agree, Rima, that we see more and more, especially digital journals, that actually invite people to publish their code, to share it openly, and with that really spur also the progress of the entire field, which is something we should not underestimate. However, and this is my closing remark on this, even if you share code, it doesn't always help. This is only a helpful hint. Coding styles differ. We don't have a standardization in that regard, typically in communities. And so this can be very challenging to dive into somebody else's code, to understand how things have been done. And then you end up typically with spaghetti code. My old postdoc used to say, I can write Fortran in any language. So I think this is still somewhat of an opinion because a lot of people are subject to delivering KPIs, and that is what their main target is, and not sharing their code, unfortunately. But the situation changes.
I can add to this a bit. It's a problem both of unavailability of code and code just not doing what it's supposed to do. And I think this can be for a number of different reasons. Some of them are perfectly innocent, others maybe not so. What I do see is that there's also a difference in the philosophy that people have about whether it's a good idea to share their materials and to share their data and their code so that other people can see what they've done. So I've read, for instance, that people think nobody should have to share their data because others can free write on it the data that they so carefully collected, and then that could be used by other people. That would kind of be unfair. So that's an opinion that I don't agree with. But what I see standing behind this actually as a matter of how we attribute authorship and give credit to work that's been done. And work that's been done is being credited only by authorship of published papers, or mostly. And if then your holy data set is being used for something else and somebody else gets a publication out of this and it's not you, then I understand that it might seem as if this is costly for you. But I think what's lacking in that perspective is the idea that as research and as science, we can only make progress if we actually have the materials available for that. If the data is available, why would we have to duplicate it and spend time and resources and money on doing it again if we could just share it? And I think something very similar goes in the direction of code. Of course, if I read in a paper what type of analysis was done, I can sit down and, assuming that I have data that looks similar, I can just draft my own code and see if I can get to the point of reproducing the results of the paper. But this costs me an inordinate amount of time. I have to do lots of guesstimations and make judgment calls about how to handle the data, what to do in my code, which packages to use, which software, and so on and so forth. So the duplication costs here are incredibly high as well, which means that if this is the case, then very few people will end up trying to do it. The best thing you can do in a way to protect your paper from attempts of reproduction is to just not share materials about it. As long as you get away with that, I think that's problematic because that means we can, as a community, not check properly what's been going on in the code behind a publication.
It touches on an important point. Yes, you're right that at some stage we publish our data anyway because we write a paper out of it. And usually you'll find some tables in there with data from the experiments and the conclusion that derive from it. At the same time, there's also some research going on. I'm thinking, for instance, of the pharmaceutical industry, where they develop new medication and they usually end up writing a patent around it. But at the same time, they obviously need to go to the health authorities where they have to get the license for the medication. And it needs to be published then. But how do they treat and how can they make their code and their data reproducible and shareable?
Actually, medical research and randomized controlled trials are a field where it's immensely important to engage in open and transparent documentation of how this research was done, which also is something that we don't necessarily see. So I think since 2010 roundabout, it has been mandatory that randomized controlled trials in the medical field are actually pre-registered. So this means that before the experiments are done, there is a public registration of what the intention of the experiment is, of the controlled trial is. And before that, that wasn't, you didn't have to publicly announce this, which meant that there was a massive amount of outcome switching, of conditions being left out in reporting, and just generally problematic practices that lead us to worry that the drugs and interventions that are being developed aren't actually reproducible. There has been a bit of a change since that necessity to pre-register these RCTs has kicked in. But what we can now do is actually compare what people or what researchers pre-registered with what they eventually published. I think there's a large project that's doing that. And it's the picture is not as great as you would hope it would be, even for that kind of facet of reproducibility, where it's just about, are you doing what you said you would be doing? The answer is often no, because what we see is that, like I said before, conditions are being left out. The main outcome that was supposed to be reported isn't being reported, and instead there is a different outcome being reported. So from that perspective, I would say in this field, there are problems that start at a different level than making your code publicly available. Often I would say probably the code is the least worry. What's more worrisome is making your data public and the data on which analyses are performed, because you would be worried about protecting participants' privacy and making sure that the sensitive data of medical participants isn't being used for anything that it shouldn't be used for. And there I would say that I understand, of course, that data privacy goes before the need for transparent reporting, but there are ways out of this as well. So you could simulate a data set that has the essential features of the data that you've been using. It would also be possible to just drop information from your data, so don't make public in which hospital this participant was treated, how old they are, and what gender they have. And it's already much more difficult to triangulate this participant and find out who they were. I think there are problems that are bigger than making code publicly available in the medical field, which kind of, from my perspective, make it more difficult to even get to the point where we're discussing the openness of code and the reproducibility of code in medicine.
Which brings us to the point that we made earlier, that actually when we talk about reproducibility, it's about two things, really. It's about the software, but it's also about the research data. Can I reproduce the data? I mean, in this case, clinical trials or the data that have been published as a result of clinical trials. In addition to the patient privacy, then there is also the commercial interests of the companies who want to protect the commercial interests in terms of patents. So how can we actually convince them that reproducibility is actually something that doesn't harm them, that doesn't eat into the bottom line, so to speak?
I have not been very much in touch with companies directly. I think even there we need to revise our assumptions a little bit. I see that especially small and medium-sized companies, there tends to be a spirit of innovation roaming them tremendously, which means that a lot of people start to believe and also make it actually their business model to work with open source data and, for example, offer support for packages or whatever. So just look at the big Linux companies like Red Hat, etc. That's what they're making their living from. And that's actually, I think, a good living. Anyway, I totally see your point. There's still a lot of concern that intellectual property gets stolen or copied or whatever, and then basically business models go down the drain immediately. However, what I typically then counter-argue is that openness actually fuels innovation tremendously. So if you are going along this train of improving other people's code, for example, and working with them and also reusing other people's data sets, for example, it's first of all, it becomes a matter of communication because people are aware of common packages, etc., and also data sets. But also it actually helps people to push forward the state of the art. And I think this is something to really contemplate at some point, because we've seen, especially in machine learning at the beginning of this year, when we record this, that openness had actually fueled innovation about large language models tremendously. And I would even argue that some of the tools that we also use in physics to analyze our data, they couldn't be there if they wouldn't be open. So it's really a totally ambivalent topic where I don't see one answer fits all. So I'm sorry to not answer your question, Peter, but I think this whole set of diversity is really the key challenges here. How people really make a living and how people embrace the exchange of information and knowledge. Because that is, at the end of the day, what openness is about, to exchange. But this simply contradicts some business models. I think that's just my observation that I started to live with.
I share the notion that openness is very much about sharing. And in part, what this openness is about is also making the thing that you're sharing about better. I think it can actually be a business model to make a better product, because you allow competitors to use your patents. For instance, Tesla does this, right? They make patents openly available, and to build on it so that eventually you can hopefully create the better product. And then based on somebody else's innovation, your own team can bring an innovation to the table again. So it's kind of like an iterative process of making the product better, where you don't restrict the brains that can be working on the problem to the brains in your own company or in your circle of researchers or whatever specific area of application this is. And it depends a bit, I think, on your theory of how knowledge generation and progress in knowledge can actually best be achieved. And whether you think that the brains that you have in your closed circle are already the ones that are the most productive on this question, or if you think that you want to prioritize making the knowledge better. And then it would actually often be helpful to get a more diverse view on opportunities for creating different ideas. So I would say that openness is often also a matter of philosophy, and whether or not like it pays to be open, I would bet that it does, but I don't have tangible numbers on this. But I would be really interested in finding out what is the idea quality or the product quality based on closed access, data code, and so on, patents, and what's the quality of ideas that come out of more open processes.
Probably difficult to ascertain, I would imagine. But I think that's a wider discussion. So let's go back to reproducible and how you can make your research more reproducible. What is it that scientists and researchers and engineers working in that area, what can they do to make it reproducible or make it more reproducible?
I would start out with saying it's a mindset. It's a mindset thing that I've unfortunately visited on both sides of the medal multiple times, and for good or bad. Basically, what I mean by this is stop considering coding and generating data as a down payment that you don't care about. So that's the first thing. Embrace it, if I may use that term. Embrace it, but don't hug too strongly. I mean, that's always a very personal choice. I've seen people embracing it too much and then, diving into software engineering and programming and forgetting about the science. But I've also witnessed the other side of the medal, namely that people don't care about it, so they really miss out on the fundamentals. On a technical scale, I would say version control, that's the best practice, reproducible software environment, something we already mentioned. Something that a lot of people miss out is tests, unit tests, integration tests, because many people are simply not aware of this concept, so that they can actually fix their assumptions also about the data in software. Then defensive programming is another idea where you can actually set out and code in and check the assumptions that you have about the data. I think we touched upon that point earlier. And something that is more recent, but is also, at least from my perspective, something that should get more awareness is, I call it blind execution of analysis workflows. So that effectively you use software tools to combine data and software to create your results automatically. And this is by virtue of workflow engines, but also by executable publications, if you think about R Markdown. So this is really now on the total technical side, a couple of key points that I think is very important. Yeah, what did I forget? I don't know. Probably
Well,
time.
if I can, I would add some more conceptual and perhaps less technical points to this list. Because when I thought about this question, what I found most helpful was the idea to actually put myself into the shoes of other researchers, or alternatively, into the shoes of my future self with a severe case of bad memory, which I know for myself isn't so far off, because when I look back at projects that I've already completed half a year ago, and then I return to them. Of course, the task switching costs are huge, but also often I don't remember the specifics of what I wanted to do with what exactly. So for me, it really helps to anticipate having such bad memory and trying to make my workflow work in a way so that my future self can still understand what I was trying to do. And I think that is a perspective that perhaps many of us can actually sympathize. So even if you don't feel like you should be changing your practice to make your work more transparent and reproducible for other researchers, a selfish reason to do it is still so that you can understand what you were doing. And as an effect, this will also have positive externalities for others. I think it's helpful to put yourself in the shoes of your future self and also in that of other researchers, other practitioners, other users of your code, your data, and try to think about what would they need to be able to do it again, what you've been doing in a couple of months, years down the road.
I think you touched upon a super important point that I actually see emerging these days very recently, namely that we don't only apply these best practices to code, but also to data. This is what Rima just reminded me of. What I mean precisely about this is that putting a blob of data online is great. It's even more great if you can use it and reuse it on your local machine. But what I've seen recently is that a lot of treasure is also contained in the metadata. In some fields, this is very structured. I can imagine, not sure if I've ever seen it, that in clinical trials, this is very standardized to describe how you effectively store the data. But in the physical domains, I have the feeling that especially this metadata, how did I conduct the experiment? Where did it come from? All this kind of stuff. And when was it recorded? What was, for example, the machine it was recorded on? So here I don't mean a computer, but really camera specifics. So really specifics about the experiment itself. Because we have to acknowledge the fact technical drawings are great to describe how an experiment was set up. But at the end of the day, especially also in the lab, it really can boil down to the version of the firmware in the hardware on which the camera was running, etc., etc. This metadata, all of these key ingredients that describe how the data was recorded, really also on a technical level, start to become really crucial, which is bearing evidence for me how good our community is really getting. Because if this is the source of the problem, then you can be sure that some of the other errors or challenges have actually been overcome.
Yeah, I completely agree. But sometimes I think when I hear all the things that we have to keep in mind to make our code and experiments reproducible and replicable and open and transparent, it sounds like there's just this huge laundry list of stuff that as a person I have to keep in mind, right? And it can be a bit daunting. But I do think that it's not necessary to do everything at once. It's important to do some steps in the right direction, in the direction of more openness and more transparency and more reproducibility. And then once you've built those into your workflow, the other steps will begin to follow, and you're kind of hooked and developing in that direction. So that's one thing I wanted to throw in.
Yes, such a lovely statement to which I would love to add, nobody's alone. I think openness is about, as we said before, sharing, and that means communication. Nobody is expected to actually leverage all of this alone. I can only invite people to join either the GRNs or the German Reproducibility Network or other networks, maybe even locally, maybe smaller networks for people in the same domain where you really speak the same language, to really share and explore what kind of steps other people take to ensure that their work is reusable. So I think this is something at the hallmark of being open, namely to actually build a bridge to other people and not be alone.
I completely agree. So I think lots of openness and transparency is about community learning, understanding best practices from others, and seeing what ideas they have to make their materials more shareable, findable, and all the other things that they need to be eventually. So I would echo this idea to seek out your local or topical groups of and communities of people who are interested in working on the same thing you're interested in working on, but make it a little more open.
And I think we touched on that a little bit earlier when we said it's a change of mindset. I've seen reproducibility workshops or hackathons where they basically take a paper that was published and try to reproduce it. But that's more or less a final step. That's not where reproducibility starts. It starts actually at the beginning of the research, is what I'm hearing. Like, you're starting formulating a concept of what it is you're trying to research. You're asking them for funding, etc. And that's when you need to bake in the reproducibility right from the onset. Did I get that right?
Yeah, I think the earlier you start to think about reproducibility in the project that you're pursuing, the easier it's going to be to actually make it reproducible or to make steps to making it reproducible. Because if you only think about this in the end, when you already have your finished paper in hand, then it becomes more complicated to share some stuff that has to do with this paper. While if you think from the beginning of the process, you can make decisions early on that will make your life in terms of sharing much easier. For instance, I'm beginning to become a huge fan of reproducible papers, where essentially you write the code and the text of the paper in one go. And as you update the code, the paper itself would update, which makes it incredibly nice for people who try to follow what you're doing, because they can just read the paper along with the, let's say, computations that you're doing in the same document. I think that can be a really helpful step to ensuring reproducibility. But what I also feel is that in making these changes, in making changes towards more openness, robustness, and reproducibility, individuals who do this actually place a bit of a burden on themselves to engage with new solutions. So if we stick with the example of the reproducible papers, it's a different process than writing your paper in Word and doing your computations in MATLAB and then just copying them over. The process of doing a reproducible paper is different in that you would, for instance, be writing the whole thing in R, and you would be using the packages that can create this reproducible paper. So sometimes you might have to learn new software, new coding skills, and you have to change your workflow around a bit. And the startup costs for that can feel pretty high. But the good news is that I think it pays out in the end, because once you've established such a workflow, you can reuse it for your next projects, and they are automatically more reproducible than what you've been doing before.
I would even go even further and add to this, it even saves your job, because effectively what it means that typically this increases the pressure of people to learn, and then you increase and expand your skill set, because typically in science, we want to compare different methods, and that forces you to use other open projects potentially. Or if nothing goes well, you have to recode other people's publications if they don't share their code. So typically at the end of the day, you really gain, which is nice. But tailoring on this, I would like to also make a point that is not often discussed, but we should actually address. Namely, that there is also becoming a larger responsibility of the funders and regulators. So right now, we basically have the thing. So you write your research proposal or whatnot, and you hand in your papers. And if you're lucky, you get your money, and then off you go and do awesome papers that you publish. And then you add this in a table, and then you hand in your report, and that's it. However, what we actually see is that the more solutions we have that are also usable, not only from a data perspective, but also from a software perspective, we get a more full-bloom spectrum of methods, which is best, I would argue, very naively, for the entire community of a field. And that is really a challenge, because talking to regulators, 2 or 3 people that I talk to, they're really stuck, because of course they want to set up rules and that are fair to everyone. But also they're stuck a little bit in the legal framework, if you will, so that everything that they really do is really legal or checkable. And that's really a challenge, I think, that we need to start talking about, not only in the scientific community, but also in conjunction with the regulators, with people from funding agencies. And from what I know, at least in Germany, this discussion has been started. Maybe even also in the Netherlands, where people from the eScience Institute have started discussing such things with their funding agencies. And I think such a discussion is also going on with the German Research Association, Deutsche Forschungsgemeinschaft. But I don't know by heart what the status is there.
Okay, we've reached the end now, and I wanted to ask about the German Reproducibility Network, how long it's been around, if you have seen any changes, and more importantly, how people can reach you.
We've been around for a couple of years. It's not a very old initiative. And we are essentially a network of networks, which means that we connect different initiatives in Germany and help them share resources and ideas, and also leverage their numbers to push for changes. And one example is that we draft comments and statements about issues that concern good research practice kind of at the broader level. Recently, we've been involved in a statement about hiring practices in German academia and the prevalence of fixed-term contracts and how that actually negatively affects research practice and research quality. We would then get members together to work on these issues, and once we have a statement, we would then share it with relevant stakeholders to get this opinion out there and get it heard, and really try to leverage the numbers that are involved. The good thing is that we do see that things are happening and are changing towards more openness and more reproducibility and robustness in research. So for instance, we see that there is more emphasis on good research practice in hiring practices. So we see when there are calls for application, for instance, they mention that researchers should be involved in open science, and they ask applicants to provide examples of how they're engaged in making their research more robust. And we also see this in promotion evaluations. And also we see that funders are increasingly asking for data management plans, so plans to make data more open and shareable, and open access publications, for instance. So we do see that things are happening, and there is a trend towards more openness, and that is being taken up as a systematic change.
And finally, how can people reach you if they have questions or if they want to join the network?
German Reproducibility Network webpage. We can, I think, add it to the show notes. And there is a contact tab where there is a mailing list, which is the best place to start, I think. And also a direct web form where people can write us a message, and we'll take it from there. So I would suggest first send us a message, and then we can share if there are communication and chat platforms, etc., etc.
Excellent. There are so many things that we haven't touched on that we could discuss for probably a few more hours, but unfortunately we've run out of time now. And I would like to thank you both very much for your time today and for this very interesting discussion. And all the best for the future.
Thanks so much.
Thank you.
If you'd like to get in touch with the German Reproducibility Network, you will find the link in the show notes. Germany is not the only country, though, with a reproducibility network, and you'll find a list of global networks in the show notes as well, along with the networks in the UK and the Netherlands. If you or your organization are interested in helping and supporting these initiatives, please get in touch with them. Let's make our research open and reproducible. Oh, time's up. See you next time. But before I forget, this podcast is covered by the Creative Commons license. See ya.